Hey everyone, in this video we're going to cover preparatory support material for Math 155 Week 11. Specifically here in this video we're going to look at four different areas, if you will. We're going to look at finding the mean of a set of numbers. Anytime you see the word mean, just think average. Computing the sum of numbers. Sum is the math word we use for the answer for addition, so 5 plus 2, the sum is 7. Computing the square roots, we're going to take a number back to its roots, if you will. I'll demonstrate more of that when we get there. And we're going to use something called the summation notation. The summation notation, it's a Greek symbol that basically tells us to add numbers up, to sum them up. So without any further ado, let's get into it. Alrighty. So here we're going to quickly just try to find the mean or the average of some values. The mathematics, and you may see this, you may not. It depends on how much detail your instructor chooses to go into or not. You know, the sum, we have a little backwards E there, if you will. The sum of given values, okay, the sum of X, basically can be found by doing this. We take the sum of those numbers, we add them all together, and we divide them by n, where n is the number of numbers. So all we're going to do here is this. We're going to take each of these values, 27.8, 36.2, 15.2, 17.8, 12.0, 3.6, 2.3, 15.6, 19.6, 4.3, and we're going to sum them. Okay, basically sum means add. So 27.8 plus 36.2 plus 15.2, etc., etc. And then we will divide them by how many numbers we have. Well, how many numbers do we have here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we'll sum all of those numbers up. We know at this point in the course that our fraction bar means divide. So at the end, we'll take the top solution, the sum of adding all those numbers together, and we'll divide it by the bottom number, which is 10, and that will give us our mean. And I realize I put the wrong symbol here. Mean is normally seen as x bar. Okay, let's rewrite that. X bar. X bar is another way of saying mean, and it is simply the sum of the numbers divided by n. I had been working on some other stuff prior to this, and that was still in my mind. So anyway, there it is. So there's our formula. Let's do the first one. Let's do the first one. And the key thing is there's always a key opportunity, if you will, perhaps. That's the way of saying it, for making mistakes, depending on what particular type of math problem we're doing. As we move beyond adding and simple subtraction and multiplication and division, the ability to make errors becomes more prominent, if you will. And when we're dealing with decimals, the number one error we're probably going to make is we don't put the decimal point in the right place. So when you're keying in, when you're typing in values into a calculator, if you will, and you're using decimals, take your time, slow down. It's usually a typo that causes you to have errors. So let's just do these. So let's go. See if you can see that. You can see that. So 27.8 plus 36.2 plus 15.2 plus 17.8 plus 12.0 plus 3.6 plus 2.3 plus 15.6 plus 19.6 plus 4.3. So the sum of these values is equal to 154.4. Okay, so we've got our top sum. We've added these up. Sum is the answer for adding. Okay, and we have what, 10 values. Let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, we do. So we're going to take that top value and divide it by the bottom. So 154 divided by 10 gives us, it gives us exactly, there's no approximate to it, 15.44. So our mean, our average of all of these values is 15.4. if we were to sort these numbers on a number line perhaps, the middle, the average of those numbers should be about 15.4. Okay, and mean is commonly seen as X bar when you're doing a sample. You're doing a slice of the pie. You don't need to know it, but you may stumble across this little symbol right here. That's a Greek symbol. It's pronounced mu, and that is the mean, if you will, of a population. That's the symbol you'll sometimes see for the population or for the mean of a population. X bar is commonly seen as the being shorthand for the average, the mean, if you will, of a sample, a smaller piece, if you will, a slice of a pie versus the whole pie. All right, let's do this other one. So we know the math now, we know the procedure, so we're just going to add these values together. We're going to sum the values of x. X is just, a variable, representing each of those numbers. So let's just go ahead and do this one. Okay, I don't know if you can see that calculator there. Let's see, 45 plus 23 plus, let me clear all that out real quick. 45 plus 23 plus 15 plus 99 plus 58 plus 36 plus 12 plus 45 plus 48 plus 75 plus 12 plus 36 plus 5. Okay, so the sum of all those values is equal to 509. We're going to divide that by the number of numbers there are. So how many do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so the sum of our values is 509. Fraction bar means divide. We're going to take the top value. We're going to divide it by the bottom value. Okay, and we'll have our mean. We'll have our average. Let's see, divided by 13. Okay, and we'll just round that to 3 decimal places. We come over here to the third decimal, which is the third number after the decimal, which is a 3. The number beside it's 5 or greater, so that tells us to round that up. So the answer is approximately, the mean is approximately 39.154, or 39 and 154 thousandths. All right, so that is finding the mean of a set of values. Okay, and this was telling us to round to the 100th. I didn't even pay attention to that. So rounded to 100. Let's see, what would that be rounded to 100? Well, how many zeros in 100? 2. So we go to the second number after the decimal, which is 5. The number beside it this time is 4 or less. So the X bar approximately answer rounded to the nearest 100 would be 39 and 15 hundredths. Okay? All right. I guess I need to read the instructions myself. Round to the nearest 100. Okay, and again, remember, if you're confused about what decimal place is in the 100 or the thousands or the 10,000ths, simply write that number out. Hundredths. How many zeros? 2. So that tells us we're talking about the second number after the decimal, second number to the right of the decimal. Okay? All righty. All right, what are we doing here? We're computing the sum of squares. Computing the sum of squares. And again, anytime we hear the word sum, we're talking about adding. Okay? That's 5 plus 2 is 7. 7 is called the sum. It's just that language of math. Okay? So the sum of squares. Well, what does that mean? Well, we're taking the results of each of these parentheses and we're squaring it. Okay, now if we remember our order of operations, I think it was back in week 3 maybe, don't quote me on that, week 3 or week 4, for some reason that rings a bell. We went through our order of operations, please excuse my dear Aunt Sally, and the P meaning, our grouping symbols, parentheses, brackets, curly braces, absolute value bars. So we're going to do the math inside of those first. And once we're done with that, we'll have exponents. So we'll do the exponents. Let's just go ahead and write them out here. Please excuse my dear Aunt Sally. Remember, anytime you have different operations, you have grouping symbols. We have exponents. We have the operation of addition. We have subtraction, etc. Anytime we have different operations, different things we're going to do to values, to terms, okay, to numbers, letters, combinations thereof. We have to follow our order of operations, and the please is our grouping symbols. I won't write them all out, but that's your parentheses, your brackets, your curly braces, your absolute value bar. E is exponents or This is where you do your roots or your radicals. Then, of course, we have multiplication, then we have division, we have addition, and we have subtraction. And hopefully we recall that when it comes to multiplication and division, we treat them the same because they're technically mirror images of each other, and we do them whichever appears first, left to right. Okay, we do math left to right. So here we're going to do what's in the grouping symbol. So let's just do that. We'll rewrite all this. So 6 minus 3 is 5. Okay, so, this has become that. Do we need the parentheses anymore? No. So we're going to take that to the second power. Plus, let's see, 9 minus 13. Hopefully we recall when we're adding or subtracting numbers with different signs. There's a 3-step process. Step 1 says ignore your signs. Okay, so we always see maybe are neutral numbers, or neither positive or negative. Step 2 says subtract the smaller number from a larger number. So 13 minus 9 is 4. 4 is our answer. We've just got to, at this point, if you will, determine whether 4 is positive or negative. Well, if we went back to these numbers here, our original values, and we imagine those being on a number line, which would be further from 0? Well, 13 would. What's the sign in front of 13? Minus. So that is minus 4. So we'll put a parentheses here to separate the plus and minus signs. Minus 4 to the second. All right, we'll do that. All right, so plus, let's see, 5 minus 10, same thing is going to apply. That's going to give us minus 5 squared. Plus 15 minus 2 is what? 13 squared. Okay. All right, so what are we going to do? Well, we're going to square each of these numbers. But there's something we've got to look out for, and I'll point it out as we go along. We got to pay attention to something here. Okay, 5 squared is simply shorthand for 5 times 5, so that's 25 plus. But this right here we got to pay attention to, because if we do this or if we do this, we're going to get two different answers. Okay. This right here, let's do this one first. This right here is shorthand for minus 4 times minus 4. Well, 4 times 4 is 16, and since the numbers have the same signs, it would be positive 16. This right here, though, technically is minus 1 times 4 squared. Okay? 4 squared would be 16, and then times minus 1 would give us negative 16. So we get 16 in both cases. It's just one is positive and one is negative. So what is meant to be occurring here? Are the parentheses meant to be there? And the short answer is probably not. I have artificially placed them there to separate our operators. Okay. In reality, here, this one right here, let's bring it up top, should be that. It should be that. So that again would be. That would be what? That would be shorthand for, if you will, minus 1 times 4 to the second, which is minus 1, 4 to the second. It's basically 4 times 4 times 16, which will give us negative 16. Okay, so this is plus negative 16. And it's going to be the same thing here. This is going to be plus negative 25. And then plus, what's 13 squared? Honestly, I don't know. Let's see, 13 times 13 is 169, plus 169. Okay, so you have to be careful of those parentheses. You have to be careful of those grouping symbols. You'll get the same math whether you'll get the same answer if you do minus 4 squared versus minus 4 squared. Here you'll get negative 16, and here you'll get positive 16. So you get the same value. But the signs will be different, if you will. You get the same numerical placeholder, if you will. So here, what are we going to do? Well, there's a couple things we can do. Let's highlight this. This is getting a little busy. We have a positive number here. We have a positive number there. The simplistic way to do this is to deal with each set of numbers by themselves, each type of values by themselves, and then put it all back together at the end. So that's what we're going to do. Let's just do it over here on the left. All right, so we've got 25 plus 169, which is going to give us what? We already got 169 in the calculator, so let's just go plus 25. Remember, addition is commutative. So we get 194 as a result of that. And then we have minus 16 minus 25. Well, remember, think of that number line. You're at minus 16. Okay, you're at minus 16 on your number line, and minus is left on the number line. You go minus 25 more, where are you now? You're at minus 41. So this is minus 41. So we got a solution from our positive values. We got a solution from our negative values. Now let's combine those. Well, basically we have 194 minus 41. 4 minus 1 is 3. 9 minus 4 is 5. So the solution to the sum of squares for that would be 153. Okay? All right, now let's do the other. Let's do the other problem. Okay? A lot of stuff just to do this, but it's an interesting concept. Your 155 instructor will go into more detail on this. So let's go ahead and do what's in the parentheses first. So we'll go 254 minus 134. We get 120 squared plus, let's go, what is that? 632 minus, I know you can't see the calculator, 580. Okay, we get 52. So this becomes 52 squared plus, okay, over here we have 403 minus 109. We have 294, so plus 294 squared. So we've found the difference. Difference means subtract. We found the difference here, 120. We found the difference of the second set of numbers, 52. We found the difference of the third set of numbers, 294. And now we're going to square each of those. Okay, even with a cheap calculator, you can do squaring. What is each of those shorthand for? Well, the first one is shorthand for 120 times 120. What is the second one shorthand for? It's shorthand for 52 times 52. And what is the third one shorthand for? Well, I think you see it. It's 294 times 294. If that had been to the third power, we would write each number 3 times. If it had been to the fifth power, we'd multiply each number times itself 5 times, etc. So let's just do this one. Let's see, 120, even with a cheap calculator, times 120. Okay, so our first value here becomes 14,400 plus, what is 52 squared? Well, that's 52 times 52, which becomes 2,704 plus, what's 294 squared? Well, that's 294 times 294, which becomes 86,436. And remember, because addition is commutative, just like multiplication, the order we do it in doesn't matter. So we'll just leave this number in the calculator, and we'll just do it from right to left. So we'll go plus 2,704 plus 14,400, and we arrive at a solution of 103,540. There's our solution. Okay? All righty. Sum of squares. Sum of squares. Sum means adding. Okay. All right. Now here we're going to compute square roots. What is a square root? You may notice in our order of operations, please excuse my dear Aunt Sally, we often say this is our exponents or our roots. Why? Well, because exponents and roots are opposites of each other. Just like multiplication and division are opposites of each other, adding and subtracting are opposites of each other. For example, if we had the square root of 100, I'll just pick a number that works, and I'll show you why I'm doing this in a minute. Okay, I'm basically saying what number times itself will give me 100. And if we do this on my little cheap calculator here, okay, I've got the radical symbol here. We call it a square root, but more technically it's called a radical symbol. I would simply type in 100 and hit the radical symbol, and my solution is 10. Basically, I have said that 10 is a number that I can square, and it will take me back to this. Okay, so these are mirror images of each other. This little place right here, this little valley, if you will, goes by different names. It's called an index. If there is no number in that index, you're being asked to find the square root of a number. If you run across something like that, and something like that, what you're being asked to do is find the number that multiplies times itself 3 different times to give you 27, and it would be 3, okay? And if we cube 3, that would be 3 times 3 times 3. 3 times 3 is 9, 9 times 3 is 27. So again, the same reality applies. They're opposites of each other, okay? So even if you listen to the language sometimes, you're taking 100 back to its roots. You're doing the square root. I mean, listen to that language. It's old language, but listen to the language. You're taking that square back to its roots. There's a reason and a rhyme, if you will, if you let it be, behind some of that language. Okay, or at least society has adopted it to mean that. So let's do the roots of these, and we're being asked to round these to the nearest hundred. Okay, most numbers, let me go ahead and talk about this. Most numbers are not what we call perfect squares. 100 is a perfect square. When we do the root of 100, we get 10. You know, if we were to do the root of 16, we would get 4. If we were to do the root of 36, we would get 6. If we were to do the root of 49, for example, we would get 7. All of these are what are called perfect squares. In other words, when you take them to their roots, you get an integer value. You get a whole number. Okay, you do not have any decimals. Perfect squares are the rarity, if you will, when it comes to roots of numbers. Most numbers are not perfect squares, and none of these are. Let's look at 85. 85 square root, well, is that, okay? It appears to be a rational number. It appears to be, once we get past a certain point, the 4s are repeating forever. So we could write this number down as 9.21954 and put a bar over that, put a bar over the 4 anyway, and it tells the observer the 4 is repeating forever, okay? So if we're going to round this to the nearest hundredth, okay, what would it be? Let's see, there's 2 zeros and a 100, so we're going to come over here to the second number after the decimal, which is the 1, and we look at the number to the immediate right. And if that number to the immediate right is 5 or greater, as it is here, it means our number goes up. So this is approximately 9.22. That is the square root, okay? That is the approximate square root of 85. Same thing for 73.5, 73.05, and we do the square root of that. Rounded to the nearest hundredth, the 4 is in the hundredths position, the number beside it's 5 or greater, so we'd have an approximate answer of 8.55. And then lastly, the square root of 24,941.1. Put that in right, 24,000. Yep, okay. And the square root is rounded to a hundredths position, second decimal place, 157. And let's see, the 2 is in the hundredth spot. The number beside it's 5 or greater. So we would round that up to 9,300. So the square root of 24,941.1 would be approximately 157 and 93 hundredths. Okay, you're going to use a calculator to do these. My generation, and I'm dating myself, is the last generation that learned how to do these longhand because we didn't have these. You know, when I was up until starting high school, these did not exist. You had to do it by hand. It's not rocket science. There's a process. It's a lot like long division, but we don't do it by hand anymore. Okay. All right. Lastly, we're going to come back to that summation symbol again, that little Greek symbol. That technically you'd call that sigma. That little Greek symbol has a name. It's sigma. That's capital sigma. Your small case sigma, if you want to know, it looks like that. The guy with a toupee. That both of those mean sigma. The Greek alphabet has uppercase and lowercase letters, just like our alphabet does. This is capital or uppercase sigma, and it's come to mean sum of. The small case sigma means standard deviation, something completely different. But anyway, so we're going to use the summation notation, okay, to find the sum rounding to the nearest hundred, and use this data here. So we're going to use this data here in each case, and we're going to work through these equations, if you will, or these expressions. We'll work through each of them. So the sum of x, well, that's kind of like what we did before when we did mean. So we're simply going to x is the place value, if you will, for all of these numbers. Okay, so we're going to go 22 plus 36 plus 14 plus 12 plus 9 plus 26 plus 5. So the sum of those is equal to 124. So that one's fairly straightforward. Okay, so the sum of the values. Okay. Here, though, it gets a little more difficult. We're going to find the sum of each of these numbers divided by 2. Okay, so we're going to take each of these digits, we're going to plug them in for x. Okay, we're going to plug them in for x divided by 2. So let's just do that. So if we go 22 divided by 2, of course we get 11. Plus, if we go 36, I'm not going to write each of these out each time. We plug in 36 next. 36 divided by 2 is 18. Plus 14 divided by 2 would be 7. Plus 12 divided by 2 would be 6. All right, 9 divided by 2 is not going to give us a decimal. 9 divided by 2 is 4.5, so 4 and 5 tenths. Plus 26 divided by 2 would be 13, and 5 divided by 2 would give us 2.5. So we had to insert each of those values for the value of x. We're doing what's in the grouping symbol. Okay, so we're going to get the solution to each of these values. We're going to divide each in half. We're going to find the average of each number, if you will. That's another way of saying it. And then we're going to sum all of those answers. So let's do that here. We've got, what do we have here? Let me get it to so we can all see the calculator. There we go. We've got 11 plus 18 plus 7 plus 6 plus 4.5 plus 13 plus 2.5. So the sum of all of those would be 62. Okay, sum of all those would be 62. All right, and this last one is pretty much the same thing. We're going to insert each of these values. 22 minus 20 would be 2. Okay, we're going to get the sum of all those numbers. Kind of doing what we did here, then at the end we're going to divide them all by 4. That's what this is telling us to do. Okay, so let's just do this. Let's insert each of these values in here. Okay, let's do this. We're going to divide them all by 4 at the end once we get a sum. So let's see. X, which is 22. 22 minus 20 is 2, plus 36 minus 20 is 16, plus 14 minus 20 is minus 6. 12 minus 20 is minus 8. 9 minus 20 is minus 11. 26 minus 20 is 6. And 5 minus 20 is minus 15. Okay. Again, what I would recommend is just add your positive values. Okay. Add your positive values together. So we'll get a solution there. So if we get a solution there, let's see, 2 plus 16 is 18, plus 6 is 24. So 24 minus, what's the sum of our negative values? We have minus 6, minus 8, minus 11, minus 15. So remember, when we're summing negative values, you think of your number line. You're starting at the first number, then you're going further left, then you're going further left, then you're going further left. So really, we're just adding these numbers together and knowing it's negative. So 6 plus 8 plus 11 plus 15, that is minus 40. So minus 40 divided by 4. So we're just rewriting that. We need to go ahead and do this piece here. Again, remember, when we're adding numbers with different signs, we're going to ignore the sign. So we don't see positive 24, negative 40. All we see is 24 and 40, neutral perhaps. We're going to subtract a smaller number from a larger number. 40 minus 24 is 16. Is it positive or negative? Well, let's see. Which of these two numbers would be further from 0 on a number line? 40 would. What's the sign? Minus. So it's going to be minus 16. So this sums to give us minus 16 over 4. Okay, so we've inserted each of these values for x. We've subtracted them from 20. Okay, so we got all our solutions, and then we summed them up. We added our positives together. We came up with 24. We added our negatives together. We came up with negative 40. Do you have to do it that way? No. Is it probably a good idea? Yes. Okay, you could just do it left or right. You go 2 plus 6 is 18. Minus 6 is 12. Minus 8 is 4. Minus 11 is, you see the difficulty there. Okay, you could do it that way, but you could just deal with each set of integers, if you will, each set of values first, your positive integers and your negative integers. All right, so we do the math here, and at the end we're going to divide it all by 4. Well, 16 divided by 4, we of course know is 4. We know what fraction bar means divide, top divided by bottom. We know it is 4, but here we have a situation where we have different signs. We have a negative sign here, and it's given that's a positive because there's no sign there generally. And remember, anytime you multiply or divide with signed numbers, and the signs are different as they are here, our answer is negative. Okay? So the sum of all those values, taking 20 away from each divided by 4, would be -4. All right, folks, that's it. Thanks.